Welcome to the Chemistry YouTube channel, Karnataka SET 2013, Part 4. Question number 31. Which of the following compounds has the lowest pKa value? Here, 4 options were given. First one, paramethyl phenol. This is a paramethyl phenol. First one. Second one is phenol. Second compound is phenol. Third compound is parachlorophenol. Parachlorophenol. And fourth compound is para-nitrophenol. So which one is? Here is a, due to plus I effect, CH3 is a electron donating group. Is a electron donating. Hence the pKa value will be larger. This is phenol. There was no electron withdrawing group and no electron donating group. Here in third compound, chlorine is a highly electronegative. Chlorine is highly electronegative. Is a electron withdrawing group. Both nitro group and Cl group are electronegative, in which NO2 group is more electronegative than chlorine. Hence option D is correct, because NO2 is a strong electron withdrawing group. Electron withdrawing group present in nearer to OH group has more acidic, hence pKa value low pKa value. Hence acidity was greater for compound D, para-nitrophenol. Hence answer is D. Question number 32. What will be the pH of a solution formed by mixing 40 ml of 0.1 HCl with 10 ml of 0.45 NaOH? You are mixing acid and base with a different molarity. So what will be the pH? You have to calculate. Let us see the answer. Molarity of HCl, M1 is given and V1 is given, that is 0.1 into 40 ml, that is 4. And the molarity of NaOH is given and volume was given, that is 0.45 molarity into 10 ml of NaOH, so it is 4.5. Here 4.5 is greater than 4. Hence by mixing this HCl and NaOH, the basicity is greater than acidity. Hence it is clear that M2V2 is greater than M1V1. Therefore the solution will be basic. So the molarity of the resultant solution is given by the formula M2V2 minus M1V1 divided by V1 plus V2. If you substitute the value M2V2, it is 4.5 minus M1V1 is 4 divided by V1, that is 40 plus 10, which is equal to 0.01. You get the answer. So POH is equal to minus log 0.01, which is equal to 2. So POH is 2, hence pH is equal to 14 minus POH, 14 minus 2, it is 12. Hence the pH of the solution is 12. POH of the solution is 2. Question number 33. According to Pearson principle, hard base, how will you define the hard base of the donor atom as? Hard base has high electronegativity. Hence the low electronegativity option A and D was ruled out. There is not low electronegativity. The electronegativity will be greater for hard base. And in among this option B and C, You see, they are given high polarizability and low polarizability. Let us take example. High polarizability, high electronegativity and high polarizability. Example, iodine. Iodine is a larger in size, which has a high polarizability. Whereas you take fluorine. Fluorine is a having high electronegativity, smaller size, small size. Hence it is low polarizability. Among this donor atom, high electronegativity and low polarizability and hard, difficult to oxidize are called as hard bases according to Pearson principle. Hence answer C is correct. Question number 34. If the reduction potential of silver plus and silver, Fe3 plus and Fe2 are given, the reduction potential are given, what is the equilibrium constant for the reaction? The reaction has been given. Delta E equal to delta E naught minus 0.05292 divided by N. Silver Fe2 plus Ag Fe3 plus is according to the equation. Ag, it is 1, Fe2 plus and Fe3 plus are equal. Hence, we will get the answer substituting the value. Here it is 0.799 minus 0.771. The minus, if we substitute the value, we will get 0.4729. So for Ag plus concentration, it will be plus 0.3363. Hence, minimum concentration of silver ion would remain unreducted by the electrode equilibrium at 0.3363 volt. Question number 35. Ionic strength of 0.01 m potassium sulfate is. If we split potassium sulfate K2SO4 gives 2K plus SO4 2 minus. Ionic strength formula is I equal to 1 by 2 into C1 Z1 square, that is half into 2 into 2 potassium, so 2 into 0.01 into 1, the charge is 1, so 1 square, plus for sulfate it is 0.01 concentration into charge is 2 minus, hence minus 2 square, that's a Z square, which is equal to 0.03 m. Answer C is correct. Question number 36. During the charging of a lead storage battery, the reaction occurring at the cathode is given as cathode. During the charging process of lead storage battery, at anode oxidation takes place. Hence lead sulfate and reacts with the water to give lead oxide and sulfate plus 2 electron. The net reaction will be lead sulfate plus H2O gives a PbPbO2 plus H2SO4 at the cathode. What happens? Cathode reduction occurs. Where this Pb2 plus takes this 2 electron, to give lead. Lead 2 plus is reduced to lead. This was a reaction occurring at the cathode. Hence, option C is oxidation reaction. It was ruled out. And B and A was hydrogen was not reduced. Hence, option A is wrong, and option D is correct. Reduction occurs at the cathode. Question number 37. Saturated solution of potassium nitrate is used to make a salt bridge because. For a salt bridge, a good salt bridge, the velocity of ion should be the same. This velocity of potassium ion and nitrate ion should be same. The velocity are not same, then the ion should not be able to neutralize. Here you have to maintain the electrical neutrality. Main is the electrical electrical neutrality should be maintained. For this, the charge of K plus and NO3 minus should be more or less nearly same. Consequently, opposite force should be developed to restrict the flow of current. Potassium nitrate velocity should be nearly same. Therefore, it is used to make salt bridge. Hence, you see in this option, velocity of potassium is greater than that of nitrate. No, it is wrong. Velocity of nitrate greater than, no. So, velocity of potassium and nitrate should be nearly same to maintain electrical neutrality. High solubility in water, it is also not correct. Option C is correct. Based on conventional transition state theory, Kr, the rate constant Kr of a bimolecular reaction is given by is Kbt by H into K double decker. Question number 39. Order of the reaction in which half-life of it does not depend on the concentration of the reactant is. For a first order reaction, T of is equal to 0.693 by K. For a second order, it is T of equal to 1 by K into A. Hence, is a first order reaction. There was no concentration term. Hence, it is a first order reaction, not zero order or second order or third order. Option is first order reaction. Question number 40. The following experimental techniques are not adequate for studying the fast reaction. Stopped flow method is used to study the fast reaction. Flash photolysis is used to study the fast reaction. And relaxation method is also used to study the fast reaction. And the conventional methods was not used to study the fast reactions. Hence, option C is correct. They are asking which was not adequate. Hence, answer C is correct. We will meet in the next video, part 5. Thank you for watching. Thank you.